Okay, this is page 8 of the scheduling notes, and we're going to talk about real-time application. What it is it's a set of concurrent tasks. So set of concurrent tasks, and this is known in the scheduling literature as a task set. That's all one word, although it looks like I put a gap there. So with your task set, all tasks share three things. The text segment, that's where the instructions are and maybe some string literals. The data segment, which is where your global variables and static variables will go, and also the heap. All tasks have their own, so if you think back to the C notes right at the end there, I talked about the memory map, and there's one thing that's missing here. That would be the stack. So each one has their own stack. That's necessary because it has all the function linkage, the local variables, stuff like that, and you can't mix those up. And one more thing, and that is the task control block, or the TCB. Is everything that the OS needs to know about this task to be able to manage it. So it's sort of like the bookkeeping for that task. So let's draw the memory map. So here's our RTOS memory map, or it's the layout in memory. So it's going to start off looking similar to what we saw before. So we had the text segment at the top, followed by the data segment, followed by the heap, and the heap goes that way. And then what we have are the task control blocks, and tasks in the scheduling literature are denoted with tau, so that's tau 1 or task 1, tau 2, tau 3, and so on. So these are where we are storing the task control blocks for each task, and then we're going to have stacks for each, and the stacks will grow that way. So task 2 stack grows that way, task 3 stack goes that way, and so on. So we have the stacks there. So TCB is used by RTOS to manage the task. The contents of the TCB are things like the task ID. So usually they have an ID number. Sometimes you can assign a name to a task. Other times it will just be the name of the first function that's called for it. Its stack pointer is something that needs to be recorded. So most information about the execution context for a task is stored on its stack, except for the stack pointer, which needs to be stored elsewhere, and that's stored in the TCB. Its state, and we have seen the ready state and we've seen the running state, and I've talked about tasks being blocked, and there's two more. A task can be inactive if you have created the task but you have not started the scheduler yet, and tasks can also have a terminated state. So their storage might stay around after they finished execution. And the priority is needed. There are some linked list pointers. So we're going to see later when we look at a couple different types of scheduling that oftentimes a task will be put into a list, and it's a doubly linked list, and the pointers for that are part of the task control block. And another thing that we've seen are the event flags, and so this will indicate what flags this task is maybe waiting for. Okay, so that's some of what's in the TCB, and this information I got from this header file. I did not mean to do red, but oh well. rtx os.h, and that one's a little harder to find than the SimSys os2 header file. This one's, an implementation specific file. I found it using the find command, which is part of, it's a Linux utility. So anyway, there's our what's in our TCB.